Good afternoon. This is the Chemistry 122 first hour exam review. I have selected 8 problems that were most commonly missed on the exam, and I will cover those. If you have any other questions regarding a problem or how I grade something on the exam, if I do not address it in the video, then please make an appointment to come to me during my office hours and we can discuss it there. First problem I'd like to cover is problem number 4. In which one of these following molecules is the center atom sp2 hybridized? So if you go to your help sheet, it says that the hybridization for the sp2 system has a combination of numbers of things attached to the center atom and lone pairs of electrons of 3. So 3 things bonded to it, 3 things. 1 lone pair, 2 things bonded to it, 2 lone pairs, 1 thing bonded to it, 3 things bonded to it, or 2 lone pairs and 1 thing bonded to it. If we draw the Lewis dot structure for these compounds, PF5, well, how many things does that phosphorus have bonded to it? The formula says 5. So it's not that one. We're looking for something that has 2 things, 1 lone pair, 2 lone pairs, 1 thing, or 3 things. NF3, 5 valence electrons from nitrogen, 7 from fluorine. 7 times 3 is 21. 26, 1, 2, 3, 4, 5, 6, 7, 8. Fluorine, that is 8 of our 26. 26 minus 8 is 18. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. That nitrogen has 3 things bonded to it, 3 fluorines and 1 lone pair. That doesn't work. Beryllium chloride. Does that beryllium have, the center beryllium, does it have 3 things bonded to it? No, it only has 2. Does it have any lone pairs of electrons? No, it's not sp2 hybridized. N2O, there the center atom is nitrogen. Five valence electrons from each nitrogen, that's 10 plus 6 is 16. 8, 9, 10, 11, 12, 13, 14, 15, 16. If we take one of these electron pairs, put it right there. That nitrogen center atom sees 8 electrons. This nitrogen atom sees 6 electrons. This has an extra pair of electrons. This overall is neutrally charged. We could represent this by moving the pair of electrons that was up there in that nitrogen to there. This nitrogen sees 2, 4, 6, 8. That nitrogen sees 2, 4, 6, 8. How many things is that nitrogen bonded to? 2 things, the nitrogen and that oxygen. Is there a pair of electrons on that center nitrogen that are not involved in bonding? No. This is not sp2. So the only thing left is SO2. The center sulfur atom is sp2 hybridized. Sulfur, SO2. Sulfur has 6 valence electrons. Oxygen has 6, but there's 2 of them, so that's 12. That's 18 valence electrons. Center sulfur, 1, 2, 3, 4, 5, 6, 7, 8. Oxygens there and there. We have 18 minus 8. We have 10 left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. one double bond between that sulfur and that oxygen atom. That center sulfur sees two things bonded to it, has one lone pair of electrons. The SO2 atom is sp2 hybridized. Next problem is problem number 6. The number of pi bonds in that molecule. All single bonded atoms are one sigma bond. So that carbon-hydrogen bond is a sigma bond. That carbon-hydrogen bond is a sigma bond. That carbon-hydrogen is a sigma bond. That carbon-carbon bond is a single sigma bond. But between these two carbons, there's one double bond. This is one pi bond. Between the carbon and the nitrogen, that has one single sigma bonds and two pi bonds. So there are two pi bonds there, one pi bond there. Answer number C is 3. Number 7. According to molecular orbital theory, two separate 1s orbitals interact to form what kind of molecular orbitals? They form the sigma and the sigma star. Where we have pi, or when we have p-type orbitals. Since we have two 1s orbitals, when we combine them and make them into molecular orbitals, we have a sigma bonding and a sigma star anti-bonding orbitals. We start out with 2 and we end up with 2. Number 8, electron. Electrons in the delocalized molecular orbitals of benzene C6H6 are combined between two adjacent carbon atoms? No. Form electron pairs in the carbon-hydrogen bonds of the compound? No, because these are the single bonds. We're talking about the delocalized molecular orbitals. These are the pi electrons. Are unevenly distributed through the molecule? No, they're evenly distributed around the molecule. Are they responsible for the fact that the bonds between the carbon atoms in the ring are longer and stronger than the bonds between the other pairs of carbon atoms in the ring? No, because every carbon-carbon bond, carbon-hydrogen bond are identical to one another. So the answer here is B, are free to move around the 6-membered ring. Let's look at number 16. The vapor pressure of a liquid in a closed container does not depend upon the amount of liquid. It doesn't depend upon the surface area of the liquid. It doesn't depend upon how big the container is. It depends upon the temperature. If I can find the actual page in the textbook where it says that, I will put that up. But the answer for number 16 is D. Number 22, a solution of two liquids that boil at a temperature more than the boiling point of either of them. This shows a negative deviation from Raoult's law. More than the boiling point. Okay. Oh, crap. Let me check. I'll have to get back with number 22. I may have to give you guys more points. I think that should be a positive deviation from Raoult's law. Number 23. The freezing point of a solution prepared from 50 grams of ethylene glycol, 85 grams of H2O. Kf, the freezing point depression constant of water is 1.86 degrees C per molal. So delta Tf is equal to K sub F times molality. What is the freezing point of the solution prepared? Well, water freezes at 0 degrees C. So we're looking at What is the freezing point of the mixture? K sub F is 1.86. The molality is moles of ethylene glycol divided by the kilograms of water. Kilograms, it is molality is moles of solute divided by kilograms of solvent. This is 0.085 kilograms. 85 grams divided by 1,000 is 0.085. Molality, moles of solute, 50 grams of ethylene glycol, C2H6O2, 50 grams C2H6O2. 1 mole C2H6O2. Put the molar mass down here, 24,632. 62 grams C2H6O2. You put this value on top, divided by 0.085. That division answer times 1.86. Move the 0 over. Your temperature should be minus 17.6. 23, and then last of all, number 25. Assuming 100% dissociation, which of the following compounds is correctly listed with its Van Hoff factor? So if these bust up 100% and remain ionized to 100%, you're looking at how many ions are produced. Well, there's 1 calcium, 1 Ca plus 2, but there are 2 ClO3 minus 1s. So there's 3 ions there. PO4 is 1 anion, so there's 1 PO4 minus 3. There are 3 ammonium cations, 3 NH4s. So 3 plus 1 is 4, not 5. Urea, no. Is a molecular compound. It does not bust up into cations and anions. Therefore, there's only one of these things per unit of urea. Scandium sulfate. How many scandium ions are there? 2. How many sulfate anions are there? 3. 2 plus 3 is not 6, but 5. Not D, not C, excuse me, not E, not D, not C, not A. 2 ammoniums, 1 sulfate, Van Hoff factor of 3. If you have any other questions, or I did not address a problem that you had a question about, please make an appointment to come back from my office. I will post another video to give you an answer to number 22 and number 16, I think it was. Because I may have to give you points back for this Van Hoff question in number 16. I will find out in 16 where in the book its specific page number for number 16, where it makes the definitive statement about temperature being related to the vapor pressure and the clarification of number 22. I'm thinking that it should be a positive deviation from Raoult's law, but I will make a definitive statement on that. Thank you very much. Again, if you have any questions about this, please don't hesitate to make an appointment for me during office hours. Have a good day.